So in this way we prove our equation, that is z square minus 2z plus 2 is equal to 0. So z square minus 2z plus 2 is equal to 0 when z is equal to 1 plus or minus I. So our answer, that is proof. Now we move to our next question. Our next question that is, if z1 and z2 are conjugate complex number and 1 minus 5i into z1 minus 2z2 is equal to 3 minus 7i, then find z1 and z2. Our only conjugate of the complex number, that is z1 and z2. So we want to first assume z1 is equal to and z2 is equal to, and then replace to our this set of equation. And z1 is equal to, first of all write x1, or write z1 is equal to x plus iy. Now conjugate of the complex number, so z2 is equal to x minus iy. So this is nothing but conjugate of z1, that is z2, just opposite sign of y, iy, that is minus iy. Now just replace our equation, that is 1 minus 5i into z1 minus 2z2 is equal to 3 minus 7i. So we want to find out z1 and z2. z1 is equal to question mark, z2 is equal to question mark. How can we find out z1 and z2? So first of all we can find x and y value and then replace x and y value over z1 and z2 equation. So ultimately our goal, that is find out x and y value. So our first step, that is just replace z1 is equal to x plus iy to our main equation, and replace z2 is equal to x minus iy to our again main equation. So this equation becomes 1 minus 5i, z1 is equal to x plus iy. So replace x plus iy minus, as it is sign, minus 2, z2 is equal to x minus iy is equal to, as it is here, 3 minus 7i as it is. Now just multiply two equation here, 1 minus 5i, that means 1 into x, 1 into iy, minus 5i into x and minus 5i into iy. So 1 into x, that is x, 1 into iy, that is iy only, minus 5i into x, that is minus 5xi, and minus 5i into iy, that is minus 5 I into y, that is I square, and then y. Now minus 2 into x, that is minus 2x, minus 2 into minus iy, minus minus becomes plus, and remaining term, that is 2yi, is equal to 3 minus 7i as it is. Now just simplify our this equation and then compare to real part and imaginary part. So x as it is, iy simplify, that is nothing but yi, minus as it is 5xi as it is, minus as it is 5 I square, that is minus 1. So here just minus minus plus, so plus 5y minus 2x as it is plus 2yi as it is equal to 3 minus 7i. Now we want to compare real part from left hand side and right hand side, and then compare imaginary part to left hand and right hand side. So 3 this is real part and minus 7 here imaginary part. So our real part from left hand side, that is x, that is real, yi that is not real, minus 5xi not real, 5y that is real, so plus 5y minus 2x that is real part, so minus 2x, 2yi that is not a real part and is equal to 3. So compare real part and compare now imaginary part, that is yi that is only y minus 5xi that is minus 5x, and this one that is imaginary, that is 2yi. So write here 2y is equal to as it is minus 7i. So our imaginary part is, that is minus 7. Now we simplify our both the equation. So here x plus 5y minus 2x, so x minus 2x that is nothing but only minus x plus 5y as it is equal to 3. Now we move minus x to right hand side, so that becomes plus x, and this 3 from right hand side to left hand side, so 5y minus 3 is equal to x. So this is our first relation between x and y. Now we can directly write x is equal to 5y minus 3 to this equation. So first of all just simplify our equation, here y and here 2y, so we can write directly 3y here and minus 5x as it is and minus 7 as it is. Now replace x value, that is 5y minus 3. So our equation that becomes 3y minus 5x is equal to minus 7, and replace x is equal to 5y minus 3. So our x value, that is 5y minus 3, so 3y as it is minus 5y minus 3 is equal to minus 7 as it is. Now just simplify 3y minus minus 5 into 5y, that is minus 25y, minus 5 into minus 3, that is plus 15 is equal to minus 7. Now again simplify 3y minus 25y, this is minus 22y, plus 15, that is left hand side we want to transfer to right hand side, is equal to minus 7 minus 15. Now again simplify minus 22y is equal to minus 7 minus 15, that is addition, and sign that is negative. So 15 plus 7, that is 22, and finally minus 22. Now minus minus cancel out, 22 cancel out, so y is equal to 1. So we find out the first case, first value, that is y. Now we want to find out x value, then and then we can find out z1 and z2 value. So we can replace y is equal to 1 to our this equation, 5y minus 3 is equal to x. So 5y minus 3 is equal to x. So y equal to 1, then replace y equal to 1, minus 3 as it is, here x, 5 into 1 that is 5, minus 3 is equal to x, and 5 minus 3 is equal to 2 is equal to x. So x is equal to 2. So our value of x and y that we can find out, that is x equal to 2 and y equal to 1. Now we want to replace z1 is equal to x plus iy and z2 is equal to x minus iy. So we just write our z1 and z2. So z1 is equal to x plus iy and z2 is equal to x minus iy. So ultimately our z1 becomes x, here 2, so 2 plus as it is, I as it is, y that is 1. So our answer that is 2 plus I, and z2 is equal to x that is 2 minus as it is, I as it is, and y equal to 1. So we can easily find out both the value z1 and z2. So using this case, we first of all must compare our real part and imaginary part, and then substitute our value x and y to z1 and z2 finally. So in this way we can got our answer. Now we move to our next set of question, that is theory, that is De Moivre's theorem. Cos n theta plus I sin n theta raised to n is equal to, here n cos n theta plus I sin n theta. For example, cos theta plus I sin theta raised to 4, that is cos 4 theta plus I sin 4 theta. And second case, that is cos theta 1 plus I sin theta 1 divided by cos theta 2 plus I sin theta 2. Then we can easily write cos theta 1 minus theta 2 plus I sin theta 1 minus theta 2. But in this case, value or theorem that is not apply when sin theta plus I cos theta. So we cannot write cos n theta plus I sin n theta, or we cannot write if cos theta plus I sin 5 raised to n, that does not equal cos n theta plus I sin n 5. That means if you want to apply, then value of the theta must be same for sin n cos, and first value that is must be cos. So this is not real case, and second one here why wrong, because of angle that is different, and here starting that is sin. We must our sin theta into I form. Now we want to find out our next question, that is cos 3 theta plus I sin 3 theta raised to 4 into cos 4 theta minus I sin 4 theta raised to 5 divided by cos 4 theta plus I sin 4 theta raised to 3 into cos 5 theta plus I sin 5 theta raised to minus 4. So write down it. First of all, we want to simplify cos 3 theta plus I sin 3 theta raised to 4 into cos 4 theta minus I sin 4 theta raised to 5 divided by cos 4 theta plus I sin 4 theta raised to 3 cos 5 theta plus I sin 5 theta raised to minus 4. So first of all by rule or by set of theory of the De Morgan's rule, we can replace power to theta that is multiply with theta, because of our rule suggested if sin theta or if cos theta plus I sin theta raised to 4 then equal to cos 4 theta plus I sin 4 theta. So using this set of theory we replace same our main question, that is 3 theta that is multiply with 4, again 3 theta that is multiply with 4, here 4 theta multiply with 5, here 4 theta multiply with again 5, again 4 theta multiply with 3, 4 theta multiply with 3, 5 theta multiply with minus 4 and 5 theta multiply with minus 4. So our equation becomes cos 3 theta into 4, that is 3 into 4 into theta plus I sin 3 theta, that is 3 into 4 into theta divided by cos 4 into 3 into theta plus I sin 4 into 3 into theta multiply with here cos 4 into 5 into theta minus I sin 4 into 5 into theta divided by same rule cos 5 into minus 4 into theta and then plus I sin